You people are still not doing quizzes? Yes, Kyra? She's giving me a big smile.
I was about to, but then I kind of forgot because I had to do my other homework.
I'm sorry about the background. I can't change it for some reason.
What's the
I think you can go
background?
to
It's
video.
okay.
Yeah, I
Background
think you
is
can
okay.
just go to video and you can change it. Like on the bottom,
Yeah,
video.
I'm trying. It's taking a while to load.
Oh.
It's
Like,
okay. No problem. But whatever is there is fine. What's wrong with it? Nothing.
okay.
Okay, so second.
I will do the quizzes over the weekend.
Okay. And Kyra, your promise? What's your promise?
Yeah, I'll also do the quizzes over the weekend.
Yeah, can you please okay, let me inform Avni. Did you check with your teacher about the
I have a class with her on Sunday.
Mhm.
I have a class with her on Friday tomorrow, but like I think I should tell her that, but she has a class right after my class, and before my class she also has a class, so I don't know if I can really
Before my class, I don't think she has any class.
No, only
Because I don't.
parents, parents can request time from her. Right?
Okay.
She has to give you time because she is the one who is mentoring you over there for this YPTC.
Yeah.
So it's her duty to give you time. Okay.
I was gonna.
Mm-hmm.
I was gonna check the quizzes.
Okay. So now let's do the last part of this study material. What is this unit going
We're,
on?
we're reading
Classification of
Section
matter.
3, classification of matter.
Yes, very good. So I try to explain you everything, and now we know about the processes: melting, freezing, sublimation, deposition. We know that they are endothermic, exothermic. If you are breaking attractions, endo. If you are making attractions, exo. Yes, Aditi?
It says that we were doing energy profiles of physical change in
Yeah,
the
we did
last
that.
class.
Mm-hmm.
And I have it written down that we would do chemical changes or something.
Energy profiles. Yes, thank you very much for reminding. Very good, Aditi. So let's do the energy profile for a chemical change.
Chemical.
I'm writing an equation here. H2, H2. Is it a gas, liquid, or solid?
It's a gas.
Very good.
It's a gas.
Yeah, reacting with O2, which is a
Gas.
Gas.
giving you water under normal temperature, means around 25 degrees Celsius. So what is it at 25 degrees Celsius?
Is it liquid? I think it's liquid
Yeah, it is liquid at 25 degrees
because the
Celsius.
boiling point is like, yeah, I think
100.
it's
Mhm.
100, and freezing point would be
it's
like
like 0 degrees Celsius.
before
So
like 0 degrees.
at 25 degrees Celsius, it is a
It's
liquid.
a
Very
liquid
good.
because
Liquid.
it's right in the middle.
Can you balance this equation?
Okay.
Mhm. How many hydrogens? How many oxygens? On the left side
2 liquid.
and on the right side?
2 hydrogens on the left.
2 on the right?
2 on the right. 2
Oxygen?
oxygens on the left. 1 on the right.
Yes.
So
You can do like 2 H2 plus O2 and then
Yeah.
2 H2O.
Very good. Perfect. Very fast. Because when you try to make this oxygen 2, then you have to multiply when you make it as 2. On this side, you have to multiply water by 2, right? You
Yeah.
have to put 2 in front of water. Then hydrogen becomes 4. So you have to put 2 in front of this hydrogen also. Very good. Kaira, perfect answer. Okay. Now here, now understand this. Do you know the name of this reaction? What is this reaction? Can I say combustion reaction? Combustion? Why it is a combustion reaction? Kaira, Aditi, Avni? Combustion is? Yes. Combustion is burning. I told you this. Burning in oxygen gas. This I told you 100 times. So please remember this. Whenever we have oxygen O2 as one of the reactant, then that reaction falls in the category of combustion reaction.
Can you hear me?
Yes, I can. It's a combustion reaction, right? And this combustion reaction, generally, all the combustion reactions are exothermic. Write on this. Somebody can ask you this. All combustion reactions are exothermic. It means, what are you learning from that teacher, Aditi, Kaira? What she's teaching?
She's like regular
In
science.
she teaches
Yeah,
regular
like-
science. In the last class, we did like maps.
Yeah,
Um,
like she does like
learning
from
about
Science
map
Olympiad.
skills.
Yeah.
Yeah, she does like events from there. I think.
Events? What? Say,
Events from Science Olympiad. Like
Like
there's different
yes,
categories like cancer to powder, road
we did
scholar,
top.
stuff like that.
We did.
And then
We did like yeah.
oh, because both of you were speaking, I could not make out. Like, let Kaira explain me. Kaira, they were saying something I could not make out. What she's
They-
teaching? Science,
to
general
me,
science.
I'm in like another like class because I'm 5th grade and they're 6th grade. So last class we were doing like symbols, basically signs,
Science,
and
okay.
then, yeah, and then
Biophysics,
we
chemistry,
sometimes
right?
do like dissections and stuff like those, but
Mhm.
it's more like general science.
Okay. Now, Aditi, can you explain what you are learning?
In the last class we did like we read a map and we
Map
basically
means?
like I forgot the name. I think it was
topographic.
Yeah,
The what?
basically.
Say again, Avni.
Topographic maps.
We
Progressive.
were reading those and
Then what
we
are they? Maps are based on bio, physics, or chemistry?
Earth science.
Earth science.
Okay. And she is making you prepare for Science Olympiad?
Yeah, like we do small events from there. Like one of like top fog.
Okay. Avni?
Yeah.
Mhm. Okay, Avni, can you tell me what?
Hello?
Mm-hmm.
Are you saying something?
Yeah, I'm saying, can you tell me what? She's trying to explain me, Aditi, but she's missing some language. Can you
So yeah. So like there's an event called Science Olympiad, and earlier we were doing things like waves and things like that, but then now she started doing Science Olympiad events, which is like a competition and there's different categories. So she's just explaining each of the events. Like we just did Road Scholar, which is like learning about like the roads and like how to read a map. Like there's like things like sectors and like townships and
Oh,
like
okay.
R and T's and stuff like that.
Okay, okay, understood. Okay. So now back to our thing. It's very important. So what are combustion reactions, Kyra?
It's basically like burning of in O2.
In O2. So what is the second reactant? What is the one of the reactant in every combustion reaction, Aditi? In every combustion reaction, one reactant is? It's written on the whiteboard. Okay.
Oxygen, O2.
O2. Yes, O2. Now, Avni, can you tell me this combustion reaction is endothermic, exothermic?
Exothermic.
So where should I write heat, Avni, if it is exothermic?
Should you write it in the products?
Yes. Heat. Now I'm going to make the energy profile for this reaction. Now understand this, children. It's very important, which even AP students, they have some difficulty, but it's not tough. Only thing you have to understand. You know that when H2 reacting with O2, what are you doing? Are you breaking chemical bonds?
No,
Yes or no? Why not?
no.
Without breaking, Avni, how can you make water? The
By
chemical,
combining them.
We can combine them.
for that you have to break the bonds first, isn't it?
Oh yeah.
Without breaking bonds, without separating hydrogen
I
from
mean,
hydrogen,
you don't
how?
have to break the bonds for the hydrogen because you have two hydrogen. You have to break the bonds for the oxygen.
But this is water. So do you think hydrogen will react with water like this? Look at this. Where is hydrogen now? On the oxygen. So if you don't break this hydrogen bond, how can you separate hydrogen and place it next to oxygen? You cannot, right? So first thing is that we have to break the bonds. So write down, during chemical reaction, it's a chemical change, right? So during a chemical reaction, chemical change, we are breaking chemical bonds of the reactants. Bonds are broken of the reactant. Is it difficult to understand? Bonds are broken. Aditi, you are getting it?
Yeah.
First, you have to break all the bonds. Break all the bonds. Bonds are broken. Bonds are broken of the reactants, not of the products. Reactant. Product is not formed yet. Now, this bond breaking, does it fall in the category of breaking attraction or making attraction?
Breaking attraction.
If it is breaking attraction, then is it endothermic, exothermic? Energy needed or energy released?
Energy needed.
Energy.
If it is, if it is energy needed, then is it endothermic, exothermic?
Is it endo-
Endothermic.
Endothermic.
Yeah. Is it clear to all of you? Let's make it. Let's make this change here. Here is the energy, this is energy profile for a chemical reaction. Energy here on this side, progress of reaction on this side. Remember earlier I was writing progress of change. Now I'm writing progress of reaction. Right? Now here, if this is the okay, 1 second, sorry. Yeah, I'm back. So if this is my, this is first step, endothermic. These are the reactants. Let's say these are the reactants. It is endothermic. Endothermic means energy going up or coming down.
Energy
And-
going up.
Energy going up.
Yeah, like this, right? Increasing. Aditi, you are adding energy, increasing. Okay, now this
Yeah,
time,
sorry.
yeah, this time, Aditi, your turn. And Kyra and Aditi. Avni, you hold your answers. I can see that you have understood this very clearly, crystal clear. Now let's see what Aditi and Kyra are going to do. I'm sure that you will be good. Don't worry. This time, the products are getting formed, products. So during formation of products, bonds are forming. New bonds are forming. New bonds are forming. Now, Aditi, Kyra, bond formation is attraction making or attraction breaking?
Attraction making.
Attraction making.
Because bond is attraction. I'm bonded to you means I'm attracted to you, right? So it's attraction making. Attraction making means energy needed or energy released?
Energy
I think energy released.
released.
Yes, energy released because energy goes down, right? Energy will be decreasing. Energy release is endothermic, exothermic?
Exothermic.
Exothermic. Yes. So it means this energy profile, first, this is bond breaking, the green one. Let's see the green one, this part. This is bond breaking, right, of the reactants, energy going up, then energy going down, like this. And if it goes down more, like this, you can see, children, like this. So mark it. The green one is endothermic process, bond breaking. Bonds are breaking. And bonds breaking in reactants. Reactants are breaking their bonds. And this one, yes, Avni, this one. Now you're free to talk, Avni. What is this one?
It's bonds like coming together, making bonds.
Yeah,
Combine.
bond formation, bonds formation. Bond formation is taking place in the products. Children, the way Avni has a slightly refined language than Kyra and Aditi. Kyra, Aditi, you must refine your language, okay? You must speak. She speaks a lot. You have seen that? That's why her language is so refined. If you speak a lot, if you speak, write, speak loudly, then your language will become much better. In chemistry, I'm talking about chemistry language. In fact, it's feasible in every subject. Every subject has okay. One second. So now this is the reactant here because you are breaking bonds of the reactant. And this is the product. Who has more energy, the reactant or product?
The reactant.
The
Very good.
reactant.
Yes,
Reactant.
yes, the reactant. And who has less energy? The product.
Product.
If I say this, we did yesterday, day before yesterday also. If I say the reactant has an energy of 100 joules, and the product has energy of 50 joules, then according to the law of conservation of energy, what happened to the energy? Where is it?
The 50
It's
joules
converted
are
into
basically
heat.
converted into heat.
50s and heat.
Yes, we
Okay,
have 50 joules of heat.
50 joules are?
In
Say again,
heat.
Heat.
in the form of heat. Where it is going? Where it is? Kyra.
It's released. Oh,
It just released.
Aditi, you also speak. Don't worry if you are slightly behind. Speak, but okay? It's released. Are you getting it, Aditi? See, there was reactant with
Yeah.
100 joules. Now products are with only 50 joules. Where is the other 50? It is released in the surroundings. So this reaction is exothermic. This is the energy profile of an exothermic reaction, right? Exothermic reaction, right? Okay. Avni, you want to rejoin the class? Avni,
Yeah.
because you're typing that you have some technical difficulty.
Oh, that was earlier, like in the beginning of the class.
Okay, fine. So please make this diagram. And I'm going to discuss now endothermic reaction. Endothermic. I'm going to erase this, children. Shall I erase it? You have made the diagram? You have written that it's exothermic? Everything very clearly, Aditi?
I took a screenshot and I'll.
But are
Um,
you getting time?
Hmm?
Are you
I just
getting?
printed out. I
Mhm.
just print them after class. I just print out all the screenshots.
Children, I just want you to discuss with your parents that once the YBTC is over, which I'm expecting by Feb end will be over, then how do you want to use your time slot? Would you like to continue learning or you want to discontinue and then start again in summers? So that you have to confirm, okay?
Yeah.
I'm
Yeah,
going to
okay.
erase this. Shall I erase this? Okay. Now I'm giving you
Yeah.
another example. There is a reaction A2. A2 is not a real chemical, just a hypothetical chemical, A2, reacting with B2, giving you 2AB. And this reaction is endothermic. Now, all three try it. Where should I write heat? Be the first one to answer. Should I write heat on the reactant side or on the product side? Endothermic means
On the
heat.
reactant side.
On the
Mhm.
On the reactant side.
What about rest of you? Kaira, Aditi?
reactant.
Okay, Aditi? Kaira? Kaira,
mhm.
where should I write heat? Yes, Kaira.
I should be on the reactant side because exothermic
Yes.
is releasing.
Yeah, on the reactant side. Good. So heat is added on the reactant side. Okay. Now, bond breaking. So which are the substances which will undergo bond breaking? The substances undergoing bond breaking.
Are they undergoing combustion?
Then
No.
B-
Here in A2, B2, AB, what
Oh,
substances will undergo bond breaking?
A2 and
A2
B2?
and
and
B2.
B2.
Yes, very good, because they are the reactant. A2 will break the bond to give you 2A. B2 will break the bond to give you 2B. Agreed? Right? This bond breaking, okay, I keep answering very fast. Bond breaking, energy needed or released?
Energy needed?
Needed.
Needed.
Energy needed. Can you answer why? If somebody
Because
says why,
Because
'Cause
breaking
Because
bonds.
breaking a
it's
bond is not
need
stable and it's
ener-
like breaking attraction. So you need energy to do that.
so why Kaira and Aditi, you cannot speak? Kaira,
Oh, 'cause
speak
I was
loudly.
like I was letting her, because then if I would start talking, it would be over each other, and then you would
Oh
hear no.
no, I know she's right. So my ears are on your voice then. Okay? My ears are always on the voice of the student who is not speaking much. So energy needed means why? Because attractions are breaking. Attractions are breaking. Okay. Don't worry if she is speaking, you can keep speaking when she is speaking. She's not saying stop, right? So make your voice louder than her. If attractions are breaking, then it is endothermic, exothermic.
Endothermic.
Endothermic.
Thermic.
Oh, she's beating both of you. Endothermic. Good. Very good. Okay. Now let's make the energy profile. Again, questions. Try to be smarter, children. Be loud, clear. What should I write here?
Energy.
Speak loudly. Who said energy?
Energy.
Yes, you're right. Why you are so scared, girl? What should I write here?
Um,
Mhm.
reaction.
Yeah,
Or
perfect. Progress of reaction. What do you mean by progress of reaction? You know, all the reactions are going from reactant to product. That's the progress of reaction. So, Aditi, what should I write here? Anyone? This is the energy of the
A2
A.
plus
A.
2, the
Plus
reaction.
two.
reactant. Yes, A2 and B2. And you are breaking chemical bonds of the reactant. So, how this will go? This will go?
It'll go up.
Up.
Yeah, like this. Energy needed. Aditi, you're getting it? Be louder, okay, and faster. Up. Bonds are broken. All bonds are broken. Now, what happens when AB is getting formed? AB formed. So during
When
formation of AB, yes,
It's
attraction.
exothermic
It's
and attraction.
attracting.
you can say bond formation, right? Aditi, be faster. See, my ears are now for you only. And keep answering Kyra and Avni. Bond formation means attraction making or attraction breaking?
Attraction making.
Attraction making.
Attraction making. Attraction making means
Exothermic.
energy is released.
Energy
Yes,
released.
energy released. Energy released means
Product.
Exothermic.
Exothermic.
what are you missing, Aditi? You're missing something. You're not following the sequence. Okay, Aditi, ask your question. What's the confusion? Aditi.
Oh.
Mm-hmm. Speak up, girl. Aditi. Okay, you're not speaking, so I'll make you speak. Okay, Aditi, answer my question. Only Aditi. Kyra and Avni, you can start making the diagram, keep writing these things. Aditi, you are with me, dear. So answer this question. What is this? This is the product or reactant? Am I audible, Aditi?
Reactant.
Oh, this one.
Or
Can you
no,
see?
that's the product.
Yeah. Don't worry. Don't be scared. Why are you so scared? We are a family. Like right now, we are all our friends, right? Don't be scared. This is the product. If you are wrong, don't worry. I'm there to correct you. This is the product, right? Now, Aditi, answer my next question. This product is formed or it was already there? After the
Formed.
reaction, formed. So when the product is formed, AB is the product. When it is formed, then bonds are forming or breaking? Chemical
Forming.
bonds forming. Bond is attraction or repulsion? Bond.
Attraction.
When bond is forming, then attractions are made or attractions are broken?
They're made.
They are made. When attractions are made, then according to that mantra in chemistry, when attractions are made, energy goes up, goes down.
Goes down.
If energy goes down, that is released, right? See, released, energy
Yeah.
released. Then that process is exothermic, endothermic.
Exothermic.
Perfect, dear. No confusion, right? Okay,
Yeah.
good. So now here, once the bonds are broken, now the new bonds are formed. I'm here in the energy profile, children. All the bonds are broken. Now bonds are forming. Should I go up or down?
Down.
Down. I'm going down, 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 and here stopped. Aditi, this is the product. The product AB, and here's the reactant A2 and B2.
I have a question.
Yes.
So basically, when these bonds are formed, since you're using A2 and B2 as an example, and like I see that you stop like above the reactants and sometimes you stop below the reactants. And so does where you stop above or below the reactants determine whether it's an endothermic or
Yes.
exothermic reaction in total?
In
And
total,
also,
yes. Mhm.
and also, for A2 plus B2, like how do you know whether it's endothermic or exothermic if you don't have the values?
No, the values will be there then. They will
Okay.
give you some values.
But
Okay.
if they don't give you values, do you
That you
just stop
cannot predict. Either they will
Okay.
give you the values or they will give you the energy profile. Otherwise, you
Okay.
cannot predict, right? We need values. We need bond enthalpies. We need something to determine. Okay. So it's a good question, Avni. Very good question. So, okay. So this process, let's say this energy here is 100 joules. And this one is here is 150 joules. So what's the energy change here?
50 joules.
50 joules.
So
50 joules.
this heat is 50 joules then. It means the reaction is like this. 50 joules of energy plus A2 plus B2 giving you 2AB. It also means, like children, I'm writing here, just carefully observe. This is 100, this is 150. I'm giving you energy of this. Let's say this is 300. Avni, Aditi, you are with me? Aditi?
Yes.
Yeah, am I audible? Aditi, don't mute yourself. Okay, don't worry.
I'm
I'm
not.
not getting,
I'm
yeah,
unmuted.
unmuted. Okay. Speak loudly with confidence. This part is bond breaking. You agree with that? Bond breaking?
Yeah.
Can you tell
Yeah.
me how much energy is needed for bond breaking? How much energy? Starting from 100, reaching up to 300. So how much needed?
200
200
joules.
joules.
200.
Joules
Yeah,
energy.
I'm writing here 200. I'm writing here. Bond breaking is 200, right? Needed. Now, can you tell me how much energy released when the bonds are formed?
150 joules.
150 joules. Very fast. Very good. This is bond formation. And this is bond breaking. Okay. You said 150 is released. This is released and this is needed. Like for example, Kyra needed some money. I gave her $200. She gave out of 200, 150 to somebody else. Then how much money is left with Kyra?
50.
50. Same is here. 200 joules of energy is needed. 150 is given. So actually how much is needed then? 50 only.
50.
200 needed. 150 given out. 200 minus 150. 50 left. Needed more. Needed more. Released less. So overall we need energy. This is endothermic. Energy needed. So these calculations are based on law of conservation of energy. Energy can neither be created nor be destroyed. It is somewhere here and there, right? The total amount is conserved.
I have another question.
Mhm.
If the rate of like if the energy required to break the bond and also make the bond, is that going to be like a chemical equilibrium?
No. Chemical equilibrium is a different concept altogether. This is
So
bond breaking.
what happens if the bond breaking energy is the same as the bond formation energy?
Then there is no change in the energy. Then neither it is endothermic nor it is exothermic. The total
So
amount of energy needed and the total amount of energy released is the same. Chemical equilibrium has nothing doing with this.
okay.
Okay, chemical equilibrium is an entirely different concept. Chemical equilibrium has nothing doing with the energies. Of course, it is the most stable form, but delta H is endothermic reactions. They also have chemical equilibrium. Exothermic reactions, they also have chemical equilibrium. So chemical equilibrium is in all types of reactions, right? So you cannot say that if delta H is same, because you must be thinking that chemical equilibrium is a state when both of them are equal in amount. No. It's something else. I'll teach you. YBTC is not asking for it. Is it okay? Okay, by the time she is rejoining the class, can you read this chemical changes? Can you read this part? What is a chemical change? Change in chemical composition.
Chemical composition.
And in chemical changes, energy changes are large. You see that in the chemical changes, you are breaking and making bonds, right? You are breaking and making bonds. So in chemical changes, energy changes are large, big amounts. And what else they have written here? You know that when bonds are formed, then electrons are being transferred, shared. That's how the chemical bonds are formed. So electrons are undergoing a change. And you can see a chemical change. Chemical change you can observe. This is a chemical change. A chemical change can be observed as change in color or formation of some solid or release of some gas. What type of reaction is this? Identify this reaction. Name this reaction.
Do you
Kyra?
mean like exothermic, endothermic, or do you mean
No,
like
no.
chemical?
Yeah,
Um,
you can say exothermic, endothermic, whatever way you want.
Which reaction?
This one,
I
combustion.
can only see
combustion.
Kyra.
It is
I
combustion. Say again.
I can only see Kyra like full screen. Oh, okay, never mind. Now I can see. Okay.
So you are enjoying her face? She has a
No, I
beautiful,
accidentally
right?
clicked like a zoom in button or something, and then it just.
Yeah. You know, you three girls, I love your faces. I've become addict of your faces. With other children, I tell them to put off their cameras. No cameras. But you three, I'm liking the camera here. Okay. So this is combustion, isn't it? And all combustion reactions are yes, all combustion reactions.
So
Burning.
thermic.
Yeah.
Exothermic.
And one of the reactant is always one of the reactant
O2.
is
O2.
Gas.
auto gas. Yes. Good. Okay. Let's make the energy profile of this combustion reaction. Energy profile is exothermic. So here is the energy. If it is exothermic, then the energy needed to break the bonds, and then energy released when new bonds are formed. The energy released is more. Go down.
More.
This is the reactant. This is the product. This is your exothermic reaction,
Yeah.
Aditi. Okay, then it
Yes.
means who has more energy during exothermic reaction, reactant or product? Answer it.
Product.
Product.
Use your brains. Don't use brain of somebody else. Look at the diagram.
Can you
Who has
repeat the
more
question
energy?
again? Can you repeat the question again?
The question is who has more energy, the reactant or product?
Reactant.
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 Yes.
Aditi and
Reactant.
Aditi and Avni.
Yeah.
You were wrong, right?
Yeah.
So write down
yeah.
this. In exothermic reaction, energy of product is less than energy of reactant. Aditi, I generally feel that you are under pressure. You are slightly tense. No? Just
No.
relax, okay? We are learning for fun. Don't worry about
Okay.
YBTC or anything. Just relax and learn for fun. Okay. This is exothermic. Can we make a profile for endothermic reaction? Endothermic reaction I'm making here on this side using this light green color. For endothermic. Endothermic. Here is the energy on this side. And this is the reactant. Energy needed to break the bonds. Right? Going up. This is
Yeah.
reactant. Then energy released when new bonds are formed. And the product will stop here. Then this is the extra amount of energy needed, right? Yeah. Yes,
Yeah.
Kyra.
So does that mean when it's going down, does that mean it's also including endothermic and exothermic?
Yeah, it
'Cause-
is always. It is
Oh, okay.
always. See, it is always. This is endo and this is exo, right? Which one is more? Endo is more here or exo is more?
Endo.
Endo. That's why the
Exo.
over
Endo.
endo.
Oh yeah, endo. Yeah,
Avni,
endo.
Avni.
Sorry, endo. Yeah.
This is more. You see, this line is going more up.
Yeah.
This is endo. This is the energy needed. And if you see, this is the energy released. So what is more? You see this
Endo.
line? Yeah, endo. So the overall reaction is endo, right? Energy needed. The way I was explaining with the money, if I gave her $200 and she gave somebody 250, then it means she's 50 less, right? But if I gave
Yeah.
her 200 and she gave only 150 to somebody, then she's with 50 extra. Same here. Energy needed, energy released, right?
Yeah.
Answer this question. Question, Kyra and Aditi. Avni, all ears up already, I know. So which one has more energy, the product or reactant in endothermic?
The product.
Aditi,
Could you repeat the question?
question is which one has more energy, the product or reactant?
The reactant.
Avni?
Oh, I thought you said I can't answer.
No, I said her ears are already up. I was
Oh.
waiting for your answer.
Oh, I thought you said I can't answer.
No, dear, no. You were wrong earlier, I remember. So that's why I was expecting. So what's the answer?
What was the question?
Oh, that's wrong. So you were not listening? I said I know Avni's ears are already up. Means you're listening carefully. The
Oh,
question.
I thought you said that I can't answer, so then I just stopped listening.
Okay, no problem. I'm asking the question, and first Kyra will answer, then Avni will answer, and then in the last Aditi will answer. Okay. The question is, in this endothermic profile, energy profile, the one which is here, you can see it. This one. Which one has more energy, the reactant or the product?
The product.
Okay, Avni, what's your answer?
The product. The product.
Aditi, what's your answer?
I change it
But why you are changing it?
because
Mhm.
you're giving energy.
Because you look at the profile. See here, this is the energy of the product, and this is the energy of the reactant. So who is down? The reactant is down.
Reactant.
They are predicting, they are answering by looking at the energy profile. So if energy profile is given, you can easily predict which one has more energy, which one has less energy. Is it okay, Aditi?
Yeah.
Which one is more stable in endothermic? Which one is more stable in endothermic, the product or the reactant?
The reactant.
Reactant.
Aditi, what's your answer? Okay. Aditi didn't answer it. So it means she is unable to recall that mantra. So any one of you can explain her. Who is ready? Kyra, would you like to explain, Aditi, why you decided reactant as stable? Yes, Kyra.
I don't
Can you
really remember the mantra, but like I remember that low energy is liked by nature because it's way more stable.
Yeah,
But
that's it.
high energy it's not liked by nature.
That's why it is unstable. That's the mantra. She's telling me the mantra. Aditi, you're not aware of this? Nature wants
I do.
low. You do, okay, but you didn't apply it here, right? Nature wants low energy because low energy compounds are stable, right? Nature wants stability. Nature is like mother. No, we call them mother nature. It's the right word. She's taking care of us. She's trying to push ourselves, or all the human society, whatever, animals, plants, everybody. She's the one who is pushing them in the direction of more stability, right? Low energy means more stable. Okay. Now, in this case, in exothermic reaction, which one is less stable? Less.
The
Which one?
reactants.
Reactant.
Okay, Aditi, which one is less stable? Can you answer? Look at the profile. Mhm. Who has more energy, the reactant or product? Aditi, this is the reactant. This is the energy of the reactant. And this is the product. And this is the energy of the product. Who has more energy, Aditi? Aditi, speak something, anything which is coming in your head.
Sorry, I was muted. The reactant, so it's less
Stable.
stable.
Oh, okay, you were speaking. Actually, when she speaks, you cannot see her lips moving. 'Cause you're slightly away from the camera. That's why. Okay. So, children, this is a very, very important concept. Let's come on the whiteboard. One last question on this concept. One last. Okay. I'm teaching you the mantra in chemistry, low energy, high energy. We are working with energy profile. We are trying to understand how we can look at the energy profiles. Energy profile. So here is the energy, right? And here is the progress of reaction. Progress of reaction. The question is slightly complicated. Be alert. The profile is going like this. This is the profile. Here is the reactant. Reactant you all know. You know very well what is a reactant. Here is the product. And here there is another thing, we call it as intermediate, which you are going to learn later on. Intermediate. And here we call it as transition state. Don't worry if you don't know these things. Don't worry. Transition state. I'm going to write down, this is also transition state. Transition state. Don't worry about these new words. You will learn them in depth later on. Reactant I'm going to write as R. Product I'm writing as P. Intermediate I'm writing as I. Transition state 1. Transition state 2. My question is very simple. Which one is the most unstable form here?
The reactants. Oh, the intermediate.
Transition.
Which
Is
one
it
is
transition
The
one?
transition state number 1.
The first transition state.
Yes. First you think and then answer, Avni. Okay. Now, which one is the most stable form?
The
The
product.
products.
Yes, very good. Which one is the second most stable?
The reactant.
The reactant.
Reactant. No,
Yes.
isn't it into?
No, dear. Reactant has less energy than
Oh,
intermediate.
stable.
Yeah,
Okay, yeah.
mm.
I was thinking unstable.
Which one is the second most unstable form?
Transition state number 2.
Number two.
Number 2. Which one is more least stable we have done? Okay. What about intermediate? Is this intermediate stable than reactant or stable than product? Or it is
More
It
It's
is
unstable. It's
it's
more unstable than both of them.
More unstable.
Yes.
the reactant and the product are more
Yeah, it is
stable.
unstable than it is a condition for intermediate, you know. It has to be unstable than reactant and product. It's
I have a
always
question.
Mhm.
So, like, is the intermediate like named like purposefully like this? Like because it's like in the middle, like because there's two of them that are more unstable than it, and two of them that are more stable than it. Is it like purposefully named like that? And every reaction is always going to be in the middle.
Yeah, it is.
Okay.
It is always in the middle. The reaction is like this. The reactant giving you intermediate. Here, reaching here. Reactant here. Energy needed to break the bonds. Energy released when the intermediate is formed. This is first reaction. Then intermediate, this one, over here. Then intermediate is breaking the bonds and then making the bonds to give you the product. When you add this step 1, step 2, when you add, intermediate cancelled and your reaction is R to P. So intermediate is something which is formed but it's not stable. You see, it's unstable and it reacts again. That's why it has to be less stable than reactant and product. Yes, Kyra.
Are the transition states from endothermic to exothermic?
Yeah,
from
the transition state is bond breaking, bond formation. You know that I was making this energy profile earlier. This one. What is this? Transition state. This one. Like here you have two, here it was only one. Okay. We are okay? Now let's come back and let's give this end to this unit. We have already understood the meaning of energies. Energy is the ability of doing work. You have understood this. Energy is the ability to do work or form heat. Work and heat, they are energies. Work has the unit of, energy has the unit of, yes, energy has the unit of, unit,
Joules and
Joules?
calories.
joules, yeah.
Joules and calories.
Work has the unit of joules or
Calories.
calories,
Joules.
joules or calories.
Joules. Okay.
Heat is also joules or cal. Joule is the SI unit. But calorie is also the unit of energy. It's not SI.
I have a question.
Mhm.
I've never quite understood like what's the difference between like the eating calories and then the energy calories? Are
Oh,
they the same thing?
no, no, no. See, eating calories are always in terms of capital CAL. One eating calorie is 1,000 other calories. The heat. This is heat. This is eating calories. So generally we say that one eating calorie is 1 kilocalorie. This is in biology. This is eating. And this is in the form of heat, in the form of energy, whatever. So eating calories are different from other calories. It's 1,000 calories is one eating calorie. Okay. So energy has a different form. So what are the forms of energy which you know? You know energy in the form of work,
Well,
the capacity of
and
doing work. You know energy in the form of
And
heat.
producing heat.
Heat, you can call it as thermal energy. Thermal means heat. Thermal, right? You know energy in the form of kinetic energy, correct?
Mhm.
You know energy in the form of potential energy. You know that? You know
Yeah.
energy in the form of electricity. Do you know that? Yes, you are using it. You know energy in the form of nuclear energy. Nuclear energy, right? All these are forms of energy. Energy can be converted into work, energy can be converted into heat, energy can be converted into kinetic energy, potential energy, electricity, nuclear energy, any other energy you know? Yes, Kyra?
I thought there was 3 SI units for energy,
Yes,
like joules and
joules. 3 SI
electric
units?
volts. I mean electron volts. Yeah, it said so
That's,
in this packet. It was like
Oh wait.
electron
yeah,
volts.
electron volt,
Yeah,
yes.
electron volts.
Electron volt, joules,
And then
calories.
wouldn't
But
for
SI is this
heat-
only.
oh, but wouldn't for heat it would be like Fahrenheit, Celsius, or Kelvin, one of those?
No, that's
Wouldn't that be
temperature,
correct?
dear. That's
Oh,
temperature.
for producing heat.
Yeah,
Okay.
okay. Temperature. Temperature is the degree of measurement of heat. How much heat generated, how much heat. It tells you the difference in the heat. It's not something when you say 20 degrees Celsius, it doesn't mean that you are telling me the heat energy of that substance. You're telling the temperature of that. It's a degree of hotness and coldness. Degree of hotness and coldness. Right? Sound is an energy. You know that when there is a big sound, the glass walls, the windows of the glass of the windows, they also start shaking. You have heard this? They
yeah.
also break down. Why they are breaking down? Why they are shaking? Because
Is it
sound
because of
has,
the waves?
because of the,
Waves.
yeah, and wave is a form of energy. So sound waves, when they come with big force, they can shake, they can break the glass. So sound is also a form of energy. Light, of course, is a form of energy. Chemical bonds, bond breaking, bond formation, they all are the form of energies. Chemical energy, exothermic reaction, endothermic reaction, they all are the form of energies. Is it okay? And I think I explained you about the potential energy and chemical energies, kinetic
Kinetic
energy.
energy.
So classification of matter is done, children. Next, I will start with unit 1. That is, I think I have to end the class very fast. My student is messaging me. This is a group tutoring, so the students cannot enter in this. This is science, a way of thinking. I'll discuss this. This is also very important. Scientific method, scientific inquiry. You will like it, definitely. Yes, Kyra.
How many more units do we have left?
Only one more.
Oh,
Nuclear chemistry.
Wasn't there some of the last ones?
Last one, yeah. This
Like,
after doing this,
oh
nuclear
yeah,
is
scientific.
left.
Isn't there 4 left? There's
I
like
read this.
2
This was
lab safety and lab equipment, then
I
radioactivity
think
and
there's
nuclear, and then
the
this
last 3.
There was like
one.
See,
Yeah.
this way
there's
this is I'm going to do.
Yeah, so the
Measurement,
first one,
this we have
10,
done.
9, and 8.
Yeah.
One
Yeah.
second.
10, 9, 8, I think as well, right?
These
I
are the
don't think we
same. These
did
are not
those.
going to take much time. I'm not counting them as unit. Okay, they are not units. I have to just give you introduction with the equipments. So we'll do it in 1 or 2 classes only. So they are not big units. Big units are these. This one and the one where I have to explain you things. When I have to explain you things, that takes time, right? But these are simple things which you already know how to measure temperature. You already know how to measure mass. All these things I have done in your unit measurement, but we'll repeat it. But they are not big. So don't worry about them, right? So see you in the next
Okay.
class. Bye-bye.
Bye.
Bye.